Okay, how we will write the counter? So for example, always at passage clock, passage reset, begin. If reset, count gets, say it's a 3-bit counter, I'm putting 3 tick B000, else if enable, count gets count plus 1. Okay, and I end this. Now this is also a clearly a incomplete if. This is clearly a incomplete if. But this is perfectly fine. Why this is fine? Let us look at the hardware. Always think of the hardware. Whenever you write the code, think of the hardware. What hardware will this translate to? I will have a flop. This is my flop. This is the register or a register. It gets the clock. It gets the reset. Now this is what is my count of 2:0. Okay. So the count, I have a reg 2:0 count. Okay. Now what happens? It is looking for a enable condition. If enable is there, count is count plus 1. Count is count. So I have a incrementer, logic for incrementer. So if there is a enable, count gets count plus 1. If there is no enable, what should be the value of count? It should latch on to the previous value, correct? Here, if no enable, count should latch on to the previous value, correct? Yes or no? Say for example, enable is there, you counted. If enable is not there, let's say you counted till 4. If enable is not there, the counter should not go to 0. It should stay put at 4. It should stay frozen at 4, correct? So at that time it should latch to 4, correct? So this is perfectly fine. So here, this is perfectly fine. This is the intended behavior. Whereas in this case, this is not the intended behavior. In a combinational circuit, I cannot have an inferred latches. This is a combinational circuit. This is not a sequential circuit here, and here I cannot have inferred latches. So whether incomplete if is okay or not okay depends upon what you are trying to do. Okay, this is a very important point we need to keep in mind. The next thing we are going to see is the case statement. Okay, case statement and if case are used inside always block. Okay, so the rule in Verilog is whatever variable you are trying to assign in case or if should be a register variable. Okay, whatever variable you are trying to assign in the if or the case statement should be a register variable. So clearly, let's say for example register, I will put say register y. Okay, always at star begin. So I will say case of select. So select is a 2-bit signal, let's say. So 2 tick B00. When select is, it's same like your switch case statement of your C program. So when case, let's say the select signal is 00, what should happen? So if just a one line, you can write it. If the multiple line, you should put begin followed by the code and end. 2 tick B01, begin, end. Okay, like this it will go on. And at last you put end case and end. Okay, this is how the case statement will look like. So it's lot easier said than done, and case statement is also going to be like a mux, correct? So the case statement is going to infer a mux. So let's say, for example, here you're going to write a condition called C1, here you're writing a condition called C2 or something. Basically, you're trying to assign Y. Okay. So effectively what it is going to do, it is creating a 4-bit 4 cross 1 mux. This is your Y. So this is C1, this is C2, this is C3, this is C4. Okay, these are the assignments that are going to happen. C3, C4 are the assignments, I'm assuming. When 2 tick B10 and 2 tick B11, what are the assignments you're going to make here? That will be the assignments here. Okay, now this is lot easier said than done. What are the important caveats with case? Let us look at that. That's because case statement is very, very dangerous to use without having understanding. Let us look at that. Okay, so first one, incomplete case statement. Again, like how incomplete if will lead to inferred latches, incomplete case will also lead to inferred latches. What do I mean by incomplete case? What do I mean by that? Say for example, I am writing, let's say the variable I am using for case is a 2-bit variable. Okay, so I am writing always at star. Okay, begin, end. Okay, here I am writing case of select. So I am writing 2 tick B00. I am writing the code here. Then I'm writing 2 tick B01. I'm writing the code here and I'm saying end case. Let's say this condition is C1, this condition is C2. So it is creating a 4 cross 1 mux because select is a 2-bit signal. So 4 combinations are possible, correct? Now this is, now when select is 0, you are giving a C1. When select is 1, you are giving C2. Now when select is C2 or C3, you have not told what should happen here, correct? You have not told. This is what is going to cause an incomplete case. Now what will happen? This will cause inferred latches. So for these two conditions, it will latch on to Y here. It will latch on. Correct? So this is very dangerous. So to avoid incomplete cases, the solution is code case with default. Code case with default. This is exactly like your C program. You're going to code a default case. So how this code will look like, I will write here. So begin case of select. So 2 tick B00, 2 tick B01. Then what we do, we write something called as default. And then we say end case. Now the moment I write default, now what is going to happen? I have not coded, see select is a 2-bit signal, correct? So what all values select can take 0001 1011. Now I have coded it for 0001. For 10 and 11 I have not coded the case statement. So when these conditions are hit, it will go and execute the default. So it will not create inferred latches. With default, we avoid inferred latches. Okay, this is very, very, very important point. Okay.